Okay, so we're going to go over this quiz together. Those of you that ever decide to watch this, these are 2 quizzes on Guru, balancing quiz and type of reactions, and we're just going to go. So how many of you think, don't lie, how many think you perfectly get this? Raise your hands. 1, 2, yeah, what we just did. 3, 4, okay, 5. There we go, because 5 people got a perfect score, so that's good. Yeah, well, that's because I gave you every answer. So, yeah, I gave you all but one. Okay, nuh isn't a word. Thank you. Okay, here we go. Let's go over every single one of them pretty quick. So, this is really the very last day we go over balancing. Ooh, scary. So here we go. Please make sure you remember, in balancing, we're trying to make the arrow become an equal sign. So we have to have the same amount of things on both sides. Now, almost 80% of people miss this problem. And I know why. Well, I think I know why. It's because you saw a 2 there, so you put a 2 right there, right off the bat. But you should not do that. Like, you can, but you're going to have to change that number. That 2 fixes the AG for a minute. But you come over here, and there's 2 O's, so you have to put a 2 right here, which now makes how many AGs? 4 of them. Okay? And then we can put a 1. Pretty cute 4, huh? So the answer is 2, 4, 1. I don't know. What do you think? Smith? What's that face for? It's okay. Are we all right with that? Does it make sense? Both sides have to have the same amount of everything. So 241 would be the answer to that one. Next up, Na plus H2O. Girls, what did I tell you to do to water? HOH. Did anyone write this down and write HOH? Good. Then you have learned. Because balancing this with H2O is way harder than balancing it if it's HOH. Because if you see OH on the other side, you should write water as HOH. So here we go. A 2 with the H means you put a 2 in front of the water. That makes 2 H's, but it also makes 2 OH's. So you got to put a 2 right there. That makes 2 OH's. That means there's 2 NA's, so you got to put a 2 right there. That didn't do anything else, so there you go. 2, 2, 2, 1. You okay with that? They are much harder to do if you do not put HOH. Next up, FeCl3, NaOH, FeOH3 plus NaCl. This one actually is the highest scoring one, which is good. There's nothing tricky on this one, really. You have 3 chlorines, so 3 there. That makes 3 NAs, so you have to put a 3 here. That makes 3 OHs, which you have, so you're done. Okay, next up, lead 2 hydroxide and hydrochloric acid makes these things. So PbOH2, there are 2 OHs. Oh, hey, HOH. So we got to put a 2 there. That makes 2 H's, 2 there. That makes 2 chlorines, which I have. So I'm done. 1, 2, 2, 1. So much easier if you put the OH. And then phosphorus plus oxygen goes to this. This is on the test. So I would rewrite this one on the front of your lab book and say, hey, this is on the test. Because if you do this, there's 5 total ones you have to balance on the test. And this will be the second. How'd it go? Who's that kid?
Except I said talk about PhD question mark, and then he said that.
Yeah, it's fine. We're good. Okay. Oh. All right. I'm going to try the half-face selfie someday. I've never tried. I've gone the whole Monty, but whatever. Here we go. So, there's only 2 that you have to balance from words. And here's one of them. So, life's okay. So here we go. First off, you would just use your naming schemata, and phosphorus is the name of a single element, but it is not on the list of diatomic ions or molecules. So it's just P. Oxygen is also, that was unique, is also a single element, but it is diatomic, right? And then the arrow. And this gigantic word gives people anxiety. I don't know what to do. There's too many letters. Well, chop it up. Right there actually should be a space. You get to a box that tells you to list the name, or sorry, put the named elements, which are P and O. And that's not hard, because that's what you had over there, right? P and O. And then the box tells you to put the subscripts from the prefixes, but do not drop and swap. So di, you would find the prefixes on the inside of your naming schemata. Diphosphorus. Penta is a 5 oxide. So far, that's what you would have. All right. Now, we would balance. And this is strange, but this one's exactly the same as a 2-3 swap, except for it's a 2-5. If you ever have an even number and an odd number, you just switch them. So the 2 goes in front of the 5, and the 5 goes in front of the 2, and then you fix the other thing you broke, which is a 4. 4, 5, 2. Okay? Put that in a box or something on your test. Or sorry, on here, not on there. No, not on your naming schemata, because I want you to memorize it, not write it on there. Well, there is no fun in that, but right? That's why I'm a teacher. Where did I lose you? Confused on how I balanced it? No, it's okay. Let me walk through it then, because you're pretty smart, so you're probably not the only one. Oh, right.
And the other 2 I didn't.
Okay. So we have to make 5 become an even number, because 2's even. So we have to double it, which makes 10, which means we have to put a 5 right there to get 10. And that is where we got our 4. Okay. All right, now, what type of reaction is this? I thought these would be way higher, and it's okay. It just means I was wrong. So 69%, that is a lot better than first hour. They were at 50-something. So let's make sure we get this. Everyone look at this box or your phone. How'd you like my attitude face? All right. What's that? Did you say it was still ugly? Oh. Okay. Yeah, she does. Hers is just half my size. Okay. In that box, you will notice 1, 2, 3, 4, 5 different types of reactions. The one at the very bottom is cut off. That's combustion. Hopefully we've done a lot of those, so you're okay with those. But what we do on those is we just march down the box one at a time, looking at these models. So a composition doesn't have a plus sign on the right. That's a dead giveaway. A decomposition doesn't, that's right. So composition, there's no plus sign on the right. You see that? A decomposition, there's no plus sign on the left. So those are the easiest ways to recognize those. Okay, and we're just going to compare them to these models every single time. A single replacement. A single replacement has a single element on both sides of the arrow, but they're not the same element. That makes sense? Single replacement has a lone element on both sides of the arrow, but it's not the same element. A double replacement reaction, it's the only type where every single thing you look at will be a compound. If there's any lone element, it's definitely not a double replacement. And then combustion, the one that's at the bottom, combustion is always just CHs, always reacting with just O2. It always makes CO2 and H2O. the most common thing that kids will get wrong on a combustion is they think it's a single replacement. But it cannot be a single replacement because there's not a lone element on the right side. Okay, so let's do this. So for just 20 seconds, will you tell your lab partner which model you think this one looks like? Ready, set, go. Pretty quiet. Which one? Good. No sneezing today? Uh-oh. Okay. It's a single replacement. Oh, no. My elbows are too fat. All right. This is a single replacement reaction because we have a lone element on both sides of the arrow. Good? Okay, next one. Will you tell your lab partner now, 20 seconds or less, what model does this appear to match? I don't hear the entire left side of the room. Is it because I'm on the right side? My fault. Perfect, Turner. Jackman, what do you think? Okay, good, because he just said the answer and I said it was perfect. Green, good morning. All right. That was good. Like, or maybe it was amen. I'm sorry. Were you praying? My fault. Okay. Is there a plus sign on the right? No. If there isn't, this is called a composition reaction, correct? Who had it right with your lab partner? Okay, next. Will you tell your lab partner what you think this is? This part right here, by the way, belongs over there. It's kind of ugly, in fact. You talk, I'll fix it. Can I fix it? I don't know how to fix it. It's tricky. Okay, what do you think, Boatwright? Single replacement reaction. That's okay. I was too. Here we go. There's a lone element on the left. I know this is ugly because this should be over there. But there's also a lone element on the right. Or, another word for lone is single. There's a single element on the left and a single element on the right. Oh, these single elements. Oh, that was dumb. Moving on. Okay, 30 seconds. What type is this? Talk with your lab partner. Or listen to these two. Or listen to music. Or sit in the back and read a book. Okay, here we go. It is a decomp. It's a decomposition because it doesn't have a plus sign on the left. Or because one thing breaks into two things. You okay with that? Okay. Okay, tell your lab partner right now. This one a lot of kids will get wrong, but hopefully not today. Everyone's scared to talk? Okay, it is a double replacement. You get what you care about, I'll get what I care about. Okay. This is why people will get this one wrong. Look at me for just a second. It'll say words, and it'll say water. Every once in a while, people think water, since it's one word, is an element. And they're like, oh, a single thing. False. I should slap you. Water's HOH or H2O. It's a compound, right? I should. I can't. Stupid loss. All right? This is a double replacement. Yes. Okay, now look. This is actually has its own type of reaction. Not that you need to know it. But this is a neutralization reaction where a base reacts with an acid to make a salt plus water. You take two very dangerous things and you make salty water out of it. There you go. So, What do we think on this one? Tell your lab partner quick. Combustion. It is combustion. Please look. A combustion always starts with C and H's, and everything else is always the same. The only thing that's different is the number of C's to the number of H's. Okay? Definitely a combustion reaction. Then words. Ooh. You don't have to write it out to know the type of reaction. Is barium an element? Yes. Is water an element? No. It's a compound. It might. Is hydrogen an element? Yes. If you have two elements on, like an element on each side, I should say, what do we call it every time? Single replacement. The barium replaces the first H in water and kicks it out by itself. Was that the last one? Okay. I want you to take 2 minutes with your lab partner and see. I know this is in your homework, but don't turn there again. See if you can get these 6 or 7 real fast. So all I'm asking is what type of reaction they are. Don't turn to your homework. I think we already have them written, don't we? Oh, if you don't have them written, then I guess do go to your homework. Okay, so let's go quick since we still have notes to do, actually. Number 6 was a what? Double replacement. Lots of stuff. Number 7, no plus sign on the right, so that means a comp. Is Thompson the only one with me? Okay, thank you. There's 2. Number 8, lone element, lone element. It is a single. Number 9 looks weird, but it is a composition. It's just a really big composition. The key is, yes, I know these are not lone elements, but the key is there's no plus sign over here. Has to be a composition. Number 10, there's crap everywhere. So what do we call that? Double replacement. Okay, then 11 through 13. No plus sign on the right, which means comp. This one, there's crap everywhere again. This is a double replacement. How about this one? Okay, who had those? Okay, so we're ready on that. Feel better about that now? Okay, the last thing. Yeah. Oh, aren't we beautiful? It's a lot better on the playback. It's actually like there. Okay, the last thing we're going to do is fill out these notes as fast as we can. I usually make you do this for homework, but whatevs. This is in the very center of your lab book. And I have 7 minutes to get through it, so you better write as fast as you've ever written in your entire life. We ready? Energy is the ability to do work or work in action. Just wanted them to see my beautiful face. Good? Moving on. Tough crap. Get your crap together. Kinetic energy is energy something possesses because of its motion. It is the energy of motion. The faster the velocity of the object, the more kinetic energy it has. These poor kids are never going to see the bottom line. The video, I can't resize it. Next, who cares? Potential energy is the amount of energy stored in something because of its relative position. This is physics. That's why we're going fast. Not really. Next. Who cares? There are several types of ways to express energy. Some examples are chemical. That's the energy stored in chemical bonds. Like when you burn something, you get heat out. That's because you're breaking bonds. Should I put an F in for 30 seconds? So you are grounded anyway. No, it's fine. I will honk as we drive by your house in driver's ed always. Yeah, I do. You live up on the hill by the sand place in Perry. Gravel pit. Still trapped. You go up that one street, you take a left, and you're like the fourth house on the left. Second house, I mean. That's how good I am. Okay, moving on. Mechanical, that's the ability to do mechanical things such as raising or lowering, expanding or contracting. Nuclear is when matter is converted to energy, usually in the form of radiation. We dropped your brother off in driver's ed forever ago.
He's 5 years older than you.
I have a really good memory. What's that? Steel trap. Nuclear is when matter is converted to energy, usually in the form of radiation. I know. Okay, I'm just kidding. Sorry. Oh, that was funny, though. Your face for just a second. He's a stalker. Electrical is expressed in the flow of electrons from one place to another. Electromagnetic is when energy is in the form of the electromagnetic spectrum, such as visible light. We're ready to go? Oh, sweet. Heat is when the energy is stored by speed of molecules and atoms in motion. It's getting close. Crunch time. We ready? All chemical reactions do something. Sometimes energy is given off, sometimes it's taken in. Yep. Yada, 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 yada. Light is given off. The word's released. Gas bubbles is given off. Yada, 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 yada. Fast. How we doing? Yada, yada, yada. Mechanical. That was too long. Electrical potentials. That's the movement of valence electrons. I'm not sure I'm giving you the best lecture here. You weren't going to pay attention anyway, right? The next blank's exothermic. That means heat goes out. Yeah, word for word. You wanted it fast. And endothermic. No, Ronnie and everyone else, what you need to know, you need the types of reaction, not types, sorry. You need the evidences of reaction, which we've gone over all year. Heat, light, gas, electricity, light change, moving on. Precipitate, that's the other one. When two liquids react to form a solid, that's our precipitate. How we doing? Boom. A sinky. Good job. Boy, we had forever. Why'd you guys rush me so much? All right, should we do the rest of them?
No.
Okay.
I'm gonna lie to myself.
Speed. Okay, have a good weekend. My heavens.